Good afternoon, and you're very welcome to AtlanTec Festival 2022. We're in the home stretch of our 8th year, and we've run a packed days, and we're just coming towards the end of our time here today. My name is Ian Gallivan. I'm a commercialization executive with NUI Galway. I kind of work at the intersection of academia and industry, and I get to see how research and industry work together, how they collaborate, and how information and data and ideas flow back and forth. So it's a very interesting place to be. Today you can follow us on Twitter at AtlanTec Fest and use the hashtag AtlanTec. I'd remind you that the Q&A function is here. Today's speaker, Rory, is speaking about a very interesting area. But before that, I just want to give a quick shout out to our sponsors. Every year they step up, and every year it's through their support that we get to have these opportunities, to have these conversations, to have these unique insights into different technologies, and to just share amongst ourselves how the technology can move and drive things forward. So today's speaker is Rory Monaghan. He's a lecturer in NUI Galway. He's primarily concerned with hydrogen and hydrogen systems and policies, and how hydrogen can play its part in addressing some of the challenges of the energy systems. If you were fortunate enough to be on Ed Gillespie's talk and on Charlie Ledbetter's talk, you'll have heard them talk about the challenges coming up in the energy systems. And Rory's talk is going to talk about where hydrogen can play a part in that, and how maybe that's one of the mechanisms by which we can address the challenges that we all know are coming in the energy systems. And with that, I'll hand over to Rory. Just remind you again, the Q&A function is there. Please use it to address any questions to Rory's talk, and we look forward to talking again after Rory's presentation. So with that, over to you, Rory.
Thank you very much, Ian. I'd like to thank Ian and the team there for giving me the opportunity to speak today, and for accommodating me while I'm out of the country. The reason I'm out of the country is related to the topic that I'm going to be talking to you about. I'm currently in Madrid at the European Hydrogen Energy Conference, and it's a really exciting place to be. And I hope that I'll give you a little flavor for where I think hydrogen could fit in a sustainable energy system for Ireland. So, whether we realize it or not, whether we buy molecules of gas from Russia or not, the European Union and we as Europeans are paying for this conflict, and we're paying for it to the tune of 22 billion euros per month. That's how much the European Union pays Russia for gas. And when you set this against the very generous humanitarian aid that is being provided to Ukraine, that's a figure of 243 million. And the numbers don't really add up. They don't really balance up. So there's something this to me goes to the root of how important energy is for our society, for our economy, and for our future. This is, most people aren't aware of this number. We're all aware of the sacrifices that are being made in Ukraine, and the attempts to help the people of Ukraine as much as possible. But when payments like this are going on in the background to maintain the economic and social functioning of our countries, there's definitely something that needs to change. Another reason we need to change is climate change. And this is just a single illustration. I'm not going to go in and show CO2 concentrations or temperature rises, but one of the impacts of climate change, and the impact that Ireland may feel the strongest, is increased intensity of winter storms. And this is just an example of storms that were in County Clare a couple of years ago. We're going to see more of these. We're going to see more unpredictable weather. That's going to have knock-on impacts in our society, in our agriculture, and in how we as a country move forward. So decarbonisation has to be our only goal. And for us in Ireland, we are absolutely blessed with renewable resources that we've only really, in the big picture, only really begun to tap into. So for the primary indicator of how we're doing on decarbonisation is our greenhouse gas emissions. And this shows our greenhouse gas emissions over the last 30 years. And what you can see, there's a couple of trends visible here, that we are at a lower emissions place than we were back in the Celtic Tiger days, but most of our emissions reductions from that time came because of the economic recession. And we've been bumping around at this slightly lower rate. We just about made our Kyoto Agreement targets. We missed our 2020 targets, and we now have really, really stringent targets to get back on track by 2030 with an aim to cut our emissions by 51% from 2018 levels. And then somehow we need to get down to net zero by 2050, because that's what the European Union has committed us to. The next 10 years will be hard. I don't know how hard the following 20 years are going to be, because even though we will have done 51% of the cutting in those 10 years, and that seems difficult, what's going to be left, the types of energy use that we're going to be needing to remove carbon from for that following 20-year period is a real challenge. So first things first, how do we get to a place of starting to decarbonize? Well, there's a number of levers we can pull. There's a number of mechanisms we can pull. First step is we just need to have an understanding of how we use energy. So I'm not going to go into this in too much detail. It's potentially a little bit confusing, but this is a type of diagram that engineers like to use. It's called a Sankey diagram, and it shows flows from inputs on the left-hand side of primary energy resources to end uses of energy on the right-hand side. And these are the broad categories that we use. So this, if you sort of look at this for a little while, you might say, well, almost all the energy that enters our energy system, this is a graphical representation of the Irish energy system. You might think that almost all of the energy that enters our energy system on the left leaves it as residential energy, as industrial energy, as transport energy. On the right-hand side, it might seem that there's a very high usage of that energy going in, a very high efficiency. But what this graph doesn't show is that most of the energy that goes into a car's engine or truck's engine or bus's engine, most of that is lost as heat. A large proportion of the energy that is supplied to houses is not used usefully for heating houses. So there's a huge lost energy resource here. And this is the first step that people should take, we as a society should take in addressing our decarbonisation challenge, and that's energy efficiency. And energy efficiency must always come first. And if I had got up here to talk to you about hydrogen energy and I had not mentioned energy efficiency, you would be fully justified in hanging up on me or asking me really hard questions at the end. The next thing that's going to be needed is societal behaviour change. Why am I showing a picture of a rainy traffic jam? Well, I'm showing you this because almost every one of those cars has just got one person in it. And this is not only an issue from climate perspective, it's an issue for a livability perspective, traffic, noise, air pollution, and the best use of public space. Is this really how we want to use our public spaces? And we in Galway are probably acutely aware of the use of public space for traffic jams. So societal behavior needs to change. What does that mean? Well, it means that we need to be using public transport more, questioning whether we need to travel as much, and making choices and being provoked, being prompted, being prodded to make the right choices from a decarbonisation point of view. And remember, I want to tie it back to that first slide. This is not solely about the climate. This is also an energy. This has always been an energy security issue, a supply security issue, but it's just really come into very sharp focus now over the last 2 months. The next step then, electrification. Electrify as much as we can, as fast as we can. We have found that the quickest route to reducing our carbon emissions, certainly in Ireland and in most countries, has been through the deployment of renewable electricity. That's things like wind in this part of the world and solar where I'm currently based right now. So if we convert as much of our electricity system to renewables, and if at the same time we try and expand the use of electricity into areas that it's not currently being used in, heating of buildings, propulsion of cars, we can start to bring that renewable electricity out of the traditional electricity sector and into these other areas that have been the domain of fossil fuels. Just something that I maybe glossed over when I showed that energy system diagram is that when many people think of energy, when many people hear the word energy, they think of electricity. But in actual fact, electricity is only 1/5 of the energy that we use. 80%, 4/5 of the energy we use is not electricity, is the direct burning of fuels for heating or for transport. So the more electricity we can get into those sectors, the easier it will be to decarbonize. And as I said, this will enable a massive renewables expansion. So we're starting to push up, at certain times of day, at certain times of year in Ireland, we're starting to push up against nearly 100% renewables on our grid. Now, our electricity grid can't quite handle that yet, but as we electrify more of our society, we will be able to bring more renewables in and avoid the import of fossil fuels. It will also enable us to start using what we in the renewables area call the real map of Ireland. This is a map of Ireland's exclusive economic zone, which briefly became famous in February when the Cork fishermen got involved with the Russian Navy. This has got some of the world's, this is probably the world's largest resource of offshore renewable energy, be that wind, tidal current, or wave energy. All of these technologies are, well, wind especially is now a commercial technology. The type of wind energy that we would need to really get into these deep offshore areas is called floating wind. That is just becoming commercialized now. Tidal current and wave energy, they're a little bit further behind, but there's a lot of work going on. But the total potential wind capacity of the Irish offshore, the Irish exclusive economic area, is 70 gigawatts. Now, is that a big number? Is that a small number? Well, our target for wind energy installation in 2030 is 12. So it really is an extremely large number. So even if we electrify our entire economy, we will still have additional resources. And what can we do with those additional resources? But what's left? If we electrify as much as we possibly can, get our cars electrified, get our homes electrified, and expand our electricity generation, what's left? Well, these are the H's, the high mileage things, the heavy things, the hot things, the hard to make things. So steel, chemicals, heavy duty trucking, buses, intercity coaches. And then we get onto the really hard things, high seas things, high altitude things. This is a 40,000 trailer equivalent unit container ship. There is no prospect that this will be electrified at any point in the future. And these ships carry 90% of goods that are consumed, whether they're products, whether they're fuels. These ships carry everything. So these ships need to be decarbonized. And the physical limitations that we have in electric propulsion systems and batteries especially makes that a challenge that cannot be met by electric systems. What else do we have? So as we go to a more renewable based system, of course, the first thing that we all recognize about renewable energy is that it's variable. Some people say it's unpredictable. It's not quite unpredictable. We can predict it with good accuracy from hours to days away. So it's definitely not unpredictable, but it absolutely is variable. And this is just data I pulled down last night from the last month of electricity demand and generation. You can get this all on the AirGrid website. It's a treasure trove of information for people that are interested in this kind of thing. You can see we've got a pretty consistent electricity demand, daily peaks. You can see the weekly pattern there with Saturday and Sunday having lower demands. So you can pick out days of the week, and on bank holidays, you can pick out an extra day of low demand. But the wind doesn't care about that. So there's our wind generation. Ireland, averaged over the course of the year, has over 35% of its electricity coming from wind. But as you can see, over the last month, over the last part of April and the first part of May, we weren't producing a particularly large amount of wind. So if we move to a highly renewable energy system, and if we have a highly electrified energy system, riding out these periods of low wind becomes extremely important. And equally important is what we do in those periods where we have too much wind. What can we do with that? There's a limitation to how much energy we can store in batteries, to how long it is feasible, economically feasible and technically feasible to store electricity in batteries. Batteries are excellent storage devices for energy for the periods of minutes to hours, maybe even up to a day or two. But if you start looking at weeks, if you start looking at months and thinking about storing the wind energy in those winter storms and using it for the calm periods in the summer, we need to look beyond batteries. So what do we have then? Green hydrogen is potentially the missing link here. What green hydrogen, first of all, I'll define what green hydrogen means. Hydrogen is a gas. It has no color. There's no way to give it a color. But hydrogen can be created from a number of different processes. It's primarily right now created by essentially cooking fossil fuels, natural gas primarily, high temperature and high pressure, and it releases hydrogen. It also releases carbon dioxide. Hydrogen is currently used as a chemical feedstock to make fertilizer in the oil and gas industry and to make steel. It's not really used as an energy source. These figures along the right-hand side indicate how it could be used as an energy source. It could be used as a fuel in vehicle engines. It could also be used more efficiently as a fuel in a device called a fuel cell. A fuel cell converts the chemical energy of hydrogen into electricity that can drive electric motors and that can make vehicles go. It can be used as a replacement for natural gas in natural gas grids and can be used to provide heat to buildings. It can be used to provide the kinds of high temperature heat that industry needs for making things like glass, steel, cement. And it can also be used as a chemical feedstock. So most of the world's hydrogen right now is not used to provide heat, or it's not used to provide any kind of energy source. It's used as a chemical to make chemicals that then contain that hydrogen. So that's things like fertilizer, that's things like polymers. So if that hydrogen is currently derived mostly from fossil fuels, but what if we connect this potential ability for hydrogen to address some of our energy demands with the fact that we are moving to a more electrified and a more renewable energy system? The alternative way to produce hydrogen, if we say we don't want to use fossil fuels to make hydrogen, because really using fossil fuels to make hydrogen for a country like Ireland just makes no sense. So we can employ a process called electrolysis. Electrolysis uses electricity to split water, H2O, into hydrogen and oxygen. And the hydrogen can be stored. And this is our battery. This is our long-term battery that can last for days, weeks, months, and can store winter wind energy to be used in the summer. Hydrogen can be stored as a gas. It can be cooled and stored as a liquid, and it can be loaded into ships and sailed great distances, and can be used as a way of trading renewable energy between countries or between continents. I was at a talk this morning in the hydrogen conference here in Madrid, and they were talking about the possibilities of setting up solar farms in Southwest Africa, in Namibia, loading up ships with liquefied hydrogen, sailing them to Germany for use to offset Russian natural gas. So these ideas are not science fiction anymore. These ideas are not being thought of by researchers. These are people, serious, sober people in charge of large companies that are now asking serious questions about where will their energy come from and how will they deliver it sustainably. So hydrogen has the potential to link our decarbonisation efforts of these very difficult sectors to decarbonize, the heavy things, the high mileage things, the high seas things, the high altitude things, while also enabling more renewables on our energy system. So this has led to a number of countries developing what are called national hydrogen strategies. And this graph shows the ambition, from low ambition on the left to high ambition on the right, for different countries in terms of the quantities of hydrogen they're interested in producing. the specific quantities aren't important, and the countries that you'd expect are to be large producers are on the right. But I've put green stars beside some of these countries. These green stars mean that these countries are prioritizing the production of green hydrogen. So that means hydrogen from renewables only. They're not going to be producing hydrogen from fossil fuels. Where Ireland comes in, where we have made some tentative, not quite commitments, but our government has made some statements in the climate action plan that was released last autumn that we will produce between 1 and 3 terawatt hours of hydrogen by 2030. So that's a relatively modest goal. We have the capacity, the potential in Ireland to produce between 80 to 100 terawatt hours. So the question becomes, how do we get to that? A number of countries around the world have also developed their strategies to say, where would they use hydrogen? So most of them are targeting the use of hydrogen in transport and industry. They're also looking at using it as that battery that I talked about for the renewable electricity sector. Countries that do oil refining can reduce the carbon footprint of their refining with hydrogen. Some are interested in putting it into buildings, and then some further ones, shipping, aviation, and a select few in mining. So this is really what I meant by that missing link statement, that it's connecting a number of different sectors in the energy system that have never been connected before, and that direct electrification would struggle to fully connect. So the EU has prioritized green hydrogen. When the EU launched a hydrogen strategy at the end of 2020, and these graphics are from that, and they had set a target for 2030 of producing 10 million tons of renewable hydrogen. Of what was called of renewable hydrogen, excuse me. What was announced yesterday in a package called a Repower EU announcement was that these targets were doubling. So we're going from 10 million tons of hydrogen produced by 2030 to 20 million. And this is as a direct response to the Russian invasion of Ukraine, that the urgency of finding replacements for Russian natural gas is more urgent now than ever. Hydrogen was not the only focus of this plan yesterday. This is a comprehensive plan to massively expand renewables, to massively expand energy efficiency measures, to reduce the time to deliver renewables projects. That's a really big issue. Ireland's first large-scale solar farm opened 2 weeks ago, and from when it was first conceived to when it was delivered was over 7 years. And we cannot afford to have key projects of national importance taking this long. So there's a whole package around reducing the time to deliver these renewable energy projects that is being worked on, and that's part of the Repower EU plan that was announced just yesterday. There's a large amount of momentum that's building across Europe at the moment, and this is some projects. These are, maybe getting a small bit technical, but these figures here, 6 MW means 6 megawatts. What I'm trying to indicate in these slides is that there are a number of operational green hydrogen projects around Europe, but they are quite small. 6 megawatts and 10 megawatts. These would be medium-sized industrial applications where hydrogen is being used to offset the use of fossil-produced hydrogen. But these are not going to address large-scale energy demands in European countries. That's where these planned projects further down the list are coming: 1,000 megawatts, 10,000 megawatts, 20,000 megawatts. These are all projects that are going to be based around the North Sea, Denmark, Germany, Netherlands. These will be using huge expansions of offshore wind energy that are coming now in the North Sea. The North Sea has traditionally been Europe's oil and gas producing area since the 1970s. Those fields are now mostly in decline, with the exception of the Norwegian part of the North Sea. But everyone else's fields are in decline, and they are now transitioning to offshore wind power. And the hydrogen is coming in as a way to replace the natural gas that used to come from the North Sea to power industry in those countries. This North H2 project for the Netherlands is aiming to completely replace the natural gas system in the Netherlands, which has got a huge chemicals production industry based on fossil fuels now, to a fully green hydrogen system that will be powered by North Sea wind. So there is some huge ambition that's coming from our European neighbours. What about Ireland? We haven't been as proactive. We haven't been doing hydrogen as long or as large scale as our European neighbours, but there have been a number of exciting projects announced. Now, what you might recognise with these is that all of these are hydrogen supply projects, and in the case of the bottom right one, a hydrogen storage project. So there is a company is interested in producing hydrogen in Northwest Mayo because they can't get an electricity grid connection to a site that has excellent wind conditions. So they want to produce hydrogen and sell it as a fuel. ESB are redeveloping the Money Point site to be an offshore wind hub, and they aim to have a hydrogen storage, a production and storage facility at the site. An Irish company, EIH2, is aiming for 2 green hydrogen production sites, one in Cork Harbour, which would be the biggest in the world, and one in Bantry Bay, which would be many, many, many times larger and would aim to export hydrogen as a fuel to European countries. But one thing that becomes clear through all of this is that where will this hydrogen be used? What will be done with it? That's not something we have addressed too much in Ireland so far. So the only real demand of hydrogen that we have in our energy system in Ireland right now is 3 trial buses that are driving in Dublin. And these were launched last summer. They've been performing well. And these are buses that would complement a battery electric bus fleet. Not every bus route is the same. Some bus routes are short and don't carry a particularly large amount of people. There is a strong likelihood that those bus routes can be adequately converted to battery electric buses. But for routes that have much longer routes, much more kilometers driven a day, shorter time to charge or to refuel, this is potentially where hydrogen fueled buses can come in. And just to reiterate, hydrogen fueled buses of this type, these are electric buses. They have electric motors that drive the wheel. The difference in a hydrogen bus compared to a battery bus is that the electricity in a battery bus comes from batteries. The electricity in a hydrogen bus comes from the device, the fuel cell, and the ultimate source of the energy in that fuel cell is hydrogen. So where could hydrogen play a role in Ireland's energy future? So if we look at different timescales, we're now having some periods of time where we have excess wind onshore. So we could use that excess wind to produce hydrogen. We could move it around the country in trucks. We could try injecting it into the gas grid. And we could use the hydrogen for operations that we currently have commercial outlets for. These are buses, and maybe we can try combining the hydrogen with natural gas in some natural gas power plants and start to gradually convert power plants that burn fossil fuels into power plants that burn renewable fuels. Over the next period of time, as we see a rapid development of both our onshore and offshore wind, we will most likely see the development of dedicated hydrogen producing renewable installations. So wind farms that are built solely for the purpose of producing hydrogen, because at some point in this period, we will start to have enough electricity coming onto our system, and hydrogen may start to get priority with some of the later built out wind farms. We now won't be able to rely on tanker trucks to move that hydrogen around anymore. There'll be too much of it. So at this point, we could be using the natural gas grid converted to allow hydrogen to be piped through it as a renewable fuel instead of using it to move fossil natural gas around. When I pointed out earlier that electricity makes up only 1/5 of the energy that we use at the end of the day, something I'd like to add to that is the natural gas grid. While we don't see it, most of us go through our day without ever thinking of it. The natural gas grid moves twice as much energy each day than the power grid. Okay, you can compare the energy moving in the power grid and the energy moving in the gas grid, and the gas grid moves twice as much. So there's a huge capacity to move energy around. We can look at storing that hydrogen from winter to summer in the depleted gas fields that we have off Cork. We're soon going to have a depleted gas field off Mayo. There are salt caverns near Belfast that can be used. In end uses, then we can start to expand the end uses into these technologies that are not quite commercial yet, but that will achieve commerciality at some time in the 2030s. And we can start to think about exporting hydrogen. Our neighbours in Europe are extremely interested in Ireland, particularly Germany. Germany is committed in its national hydrogen strategy to fully decarbonize its industry. Germany has a lot of heavy industry that relies on natural gas. They have committed to decarbonize, but they will not have enough hydrogen from all the renewable resources in Germany. There's just too much energy use, too many people. So they have a government appointed position of hydrogen commissioner, and the hydrogen commissioner's job is to travel the world and to make arrangements with countries for supplying green hydrogen to Germany. And that commissioner traveled to Ireland and met some of us working in hydrogen research in October. And he's very excited about the prospects for Ireland becoming an exporter of energy. And this would be turning on its head the recent history of Ireland, which is that we are one of the most import exposed countries in Europe when it comes to our energy. And then beyond 2040, we're still using our large-scale energy resources. We're now thinking about things called power to X. What does power to X mean? Well, this means, can we move beyond hydrogen? Are there more useful products that we can turn the hydrogen into, the X? Around this time, we'll start to see aviation and shipping becoming cost-effective and cost-competitive. These are going to be the last transportation modes to be decarbonized, just because they are so challenging, and it is so difficult to find anything that matches the energy density, the mileage that we get from fossil fuels. And the ultimate goal that we're going to have as we approach 2050 and our net zero target is full decarbonization of the energy sector, of what we call the hard to abate sectors, those things that can't be easily electrified, and energy security. So kind of summarizing what all of that might look like in Ireland, what might we have? Well, we'll have a highly energy efficient, well insulated, almost fully electrified building stock. Most buildings will be heated and cooled by heat pumps, because that's if we're building new buildings, that is by far the most efficient method of heating and cooling. Widespread use of public transport and active transport. So that's societal change. Mass electrification of cars and vans, and of domestic heating, as I pointed out. What I'm calling an Apollo program, or one could even call it a COVID-19 response for onshore and offshore wind, to really get these things built out as fast as they possibly can. Because without the resources coming on stream, we will not have the energy available to do all of this electrifying. So that means onshore and offshore wind, solar, tidal, wave, geothermal. We can't be fussy about what we want to use in Ireland. We need to use it all. Green hydrogen, I believe, will be playing a role in our heavy transport, in our buses, in our coaches, in our trucks, getting on and off the island. We'll have large-scale energy storage using combinations of batteries and hydrogen. So batteries for very efficiently and cost-effectively storing energy for minutes, hours, days. Hydrogen for the seasonal storage I've been talking about. And I do believe that we will be, at this point, an energy exporter, a fully renewable energy exporter, via interconnections for electricity to Britain and to France, and shipments of Irish green hydrogen to countries further afield, to Germany, to other countries, to North America. There's countries that are from very, very far away in the world are interested in the potential of Ireland producing hydrogen. The potential of Galway in all of this is enormous. Galway is located right in the middle of the best wind resources in Europe. hands down the best in Europe. And we have end users here in Galway. It's a relatively tightly knit city. We have transportation systems that can be decarbonised. We have industrial energy users that can be decarbonised. We have a long tradition of innovation here in Galway with our medtech industry, with our computer science based industries that are starting up here. We've got highly skilled and educated workforce, outward looking, and to try and move this along, a number of organizations, including NUI Galway, have launched an initiative called the Galway Hydrogen Hub. And this is an attempt to develop a renewable hydrogen fueled transportation hub in Galway that will serve buses and trucks in the first instance, but then hopefully move towards ships and small aircraft in the coming years. So as I said, this is moving beyond science fiction. This is moving beyond the research realm. This is becoming a reality. This is a picture that I like to show when I'm talking to my students about hydrogen and what possibilities there might be for a cleaner energy future. This is the moment that the first stage rocket of the Apollo 11 mission disconnected and dropped back down to Earth, and the second stage rocket carried on its journey, and the astronauts are safe and sound up near the top of that rocket. I kind of view this as the dawn of the hydrogen age. This was the mission to the moon. The first stage of the rocket that had the raw power to get it up out of the Earth's gravity, that was achieved by kerosene. That was a fossil fuel. The second stage, and you can see it's a much cleaner burning flame, that second stage is hydrogen powered. And hydrogen power took people to the moon in terms of propulsion. It provided their electricity while they were in space. So hydrogen was developed many, many decades ago and achieved great things. And that's where I think we are now. I think we are at a turning point for hydrogen technologies, and I see it as playing a very important role alongside energy efficiency, alongside behavioral change, and alongside large-scale electrification of our society. So I'm done with that, and I'm very happy to welcome any questions that you might have.
Thank you very much indeed, Rory. It's a fascinating insight into an area that we just have to make realizable. It strikes me as something that it's not something we talk about, it's something we do. We need to get involved and get started. And as Rory said, that the Q&A section is there for anybody who wants to pose some difficult questions to Rory. I'll try myself if I can come up with some difficult ones or not. Recent innovations in the battery space has lengthened their lifetime in terms of storage. And one of the things that you pointed out earlier was the lifetime of the storage and the durability of the storage. Battery versus hydrogen, is that complementary? Is it a static view? Is one technology over the other always going to have a dominant position, or different uses, or what?
They're fundamentally different uses. As I see it, the battery. Let's talk about where batteries comfortably beat hydrogen. Batteries respond 10 times faster than hydrogen. If you're demanding energy quickly, a battery will deliver that much quicker and much cheaper than hydrogen will. So when we talk about things, when we need a fast response with energy, batteries win hand down. Batteries are easier to work with too, because they're more efficient. We don't have to worry about this gas. We start with electricity, we store it in a battery, and we finish with electricity. And that round trip is very efficient. But the sheer quantity of batteries, and this is allowing for improvements in technology, the sheer quantity of batteries needed to store energy for, say, a week would work out as being 10 times more expensive than storing the equivalent amount of energy as hydrogen. And that's even allowing for all of the inefficiencies of going from electricity to hydrogen and back. It's just, once we have that hydrogen, it is so dense, so much denser than batteries, that the producing of it is difficult. or sorry, not difficult. The producing of it has some inefficiencies, but once you have it, it's there and it's not going anywhere.
So just on the point of response, because you spoke about the H's, didn't realize there's so many H's, but I suspect those H's have different characteristics with regard to the immediacy with which they need to convert energy in its stored form to energy in its usable form. So is that kind of a natural fit, or are those H's just a challenge and you're trying to see if hydrogen can step up, or are batteries equally applicable there, or what?
Yeah, that's it. So some of those H's are just they need hydrogen because of the chemical nature of hydrogen. So those, what I described there is the heavy things, steel making needs hydrogen because of the fact it is hydrogen. It's got molecules of hydrogen, and whether we electrify other parts of the economy or not, these processes will still use hydrogen. And together, taken together, these steel making, concrete making, fertilizer making is about 6 to 8% of global carbon emissions is associated with those. Now, we don't have many of those big heavy industries in Ireland. So thinking in Ireland's case, we have maybe a different route if we're interested in getting hydrogen into the marketplace. We have our disconnected, not well planned cities. We have transportation in Ireland relies on road, relies on long distances. So I see there being a natural advantage for hydrogen there. I also see Ireland's location as being relatively near to Germany, to the Netherlands, to these big users of fossil hydrogen, that we could be a supplier there. And, I don't see it being inconsistent to say we need, we have a role for hydrogen in Ireland, and we also have a role for hydrogen in export. I think one drives the other. The scale that would be needed to export in an impactful way to Germany would reduce the costs of the hydrogen we use here in Ireland.
Okay, there's a very good questions come in, and it crystallized a question that's in the back of my mind as well. That's more a question of, the plant. What's the life cycle of a hydrogen production plant? Because we think in terms of the money points and what have you, but what would it look like? What would the life cycle be? What's the analogy, I suppose, in the hydrogen production world?
Yeah, like the analogy at the minute is probably close to a wind farm. A wind farm right now would operate for about 20 to 25 years and would be decommissioned. And at that point, you'd either return that wind farm site to nature, or you would what's called repower it, put modern generators on the old turbines and modern blades. So this has been done at a couple of early wind farms. Hydrogen would be probably quite similar. We'd be talking a 20 to 25 year lifetime for the technology, and but it would. There's constant upgrades and repairs that would be made to the system along the way. I see the question there has got talking about nuclear power. Nuclear power would be a much longer term investment. Like there's nuclear power plants right now that are maybe 60 years old that are still running. And they are, sorry, there's plants running now that will run until they're 60 years old, pardon me. So they are so expensive, they need to earn for a very long lifetime.
And but the core hydrogen production element is the electrolysis.
Yes.
So that's the point at which the electrical energy meets water through the electrolysis process and produce hydrogen. Exactly. So those are kind of modularized, or are they large plant, or what in terms of the scale?
At the moment, those are So this is actually probably the number one topic of discussion at the conference in Madrid here is scale up. So I talked about those existing green hydrogen plants in Europe are on the order of 10 megawatts, and that would like a couple of wind turbines blowing on a windy day would provide enough electricity to run a 10 megawatt plant. 3 or 4 wind turbines, say. But what's needed in terms of making a dent in our natural gas use is 1,000 times that, is gigawatt scale plants. And the companies right now, they seem to be indicating that, well, if we can sell you a 10 megawatt plant in a container off a truck, we'll just sell you 100 of those to make a gigawatt size plant.
Yeah.
Most people don't think that's feasible. There needs to
Okay.
be a massive, there does need to be thinking of, there's advantages to modularity, but when you've got 100 modules, you need that space for 100 modules. So there does need to be a new level of consolidation where we see a bigger single module.
So there's a couple of really good questions coming through. I mean, I'll just there's a question about using gravity. I might just come back to that in a second, because I just want to follow through on this plant question, because there's a question about CHP, combined heat and power plants, running on natural gas. Can they be converted? And it kind of speaks to how we can utilize or reimagine or reuse plant, and you spoke about the gas grid moving a multiple of the energy grid, but similarly in terms of plant, can natural gas plant be repurposed for the hydrogen world?
It can, and that's underway at the moment. A natural gas power station in the US has just been refitted, and it'd be a very, very similar technology to the quite modern natural gas plants that we have here in Ireland, has just been retrofitted to burn 50% hydrogen. So this is still at the phase beyond research now. This is at a kind of a demonstration phase, but there is no hard limit that says you cannot burn hydrogen in natural gas engines. There are just modifications that need to be made. Now, these modifications need to be, the cost of making these modifications in a gas power plant, the modifications are relatively easy because they're in an industrial environment. If we're talking about having to dig up a street to change a meter on a gas grid, we need to balance that cost and that inconvenience against just decarbonizing electricity using a different way. So no one has really thought of the big picture costs and benefits of this.
But that's part of the work that you're doing and promoting and driving as well, Rory. So
exactly.
That's where the policy parts will come together again. But I mean, just looping that back to the H's again, the transition of, let's call it a former natural gas H to a hydrogen H, is there lower transition costs, higher transition costs, or it's just something you burn?
At the moment, it would be a negative transition cost, because the cost of natural gas right now, if this cost continues for the next couple of months, when large gas users will start to lock in their prices for the coming year, it will be cheaper to use green hydrogen than it will be to crack natural gas and do it the carbon intensive way, just because the feedstock is so expensive now. The price of natural gas has quadrupled in the last 6 months. So it's just the economics of green hydrogen for these sectors that already use hydrogen has been turned on its head in the last couple of months.
And so there's just, I suppose, two related questions. One is the use of gravity to generate electricity. In one sense, you're indifferent to the source of the electrical power. There can be many sources of driving electrical power. I think what you're primarily concerned about is the harnessing of all manner of renewables.
Yeah. Like I guess so like gravity right now, gravity is the world's largest energy storage technology that's being used. It's used in a technology called pumped hydro storage. And we have a plant like this in Ireland. It's in the Wicklow Mountains. And it basically, when we have spare electricity, say at night, it pumps electricity up, or pumps water up a hill from a lake to a reservoir. And then when we need extra electricity, it lets the water flow back down through turbines and do that. So gravity is, and about 85 to 90% of the world's stored energy is in that form. So that is a tried and trusted, really highly mature way of storing energy. The challenge is that you need the terrain. You need mountains, you need river, you need mountains, and you need lakes. And these would be classified as kind of engineering mega projects doing things like this. And they are getting harder and harder to do, particularly in this part of the world. That there are other companies, and perhaps this is what gravitricity is doing, that sort of raises and lowers blocks of concrete. I'm not using the same principle of using spare electricity to raise it, and then letting it fall and generate electricity. I'm not quite sure of the economics of that. I don't know if the economics stack up in the long term.
And just on to economics, and there's a question about hydrogen having the potential to enable data centers, and almost like there's a massive production potential and capacity off our shores, and a limited grid within the west of Ireland. Can the two sort of connect up and sort of enable maybe a new wave of data centers or energy intensive industries in the west?
I would certainly hope so. And one of the researchers in my team now is specifically looking at that, at seeing what new opportunities could be brought to the west of Ireland from if you look at what industries need a reliable supply of electricity and hydrogen, what can we bring here? Could we make some of the things that we have taken to importing in the past? Can we make fertilizers here? Because we used to make fertilizers in Ireland, but we don't do it anymore. But we could, and it would increase the viability, the environmental sustainability of our agriculture sector. We could also, data centers are extremely interesting, because while Ireland doesn't have the steel industry or the chemicals industry of Germany or Holland, we do have the data center industry, and it consumes a quarter of our electricity now, and they are under a lot of pressure to move to fully renewable operation. And so obviously data centers need to run 24/7, absolutely no interruptions. The wind doesn't care about that. So hydrogen is seen as, again, complementing batteries as a way to smooth out that use, that supply of energy, to provide that smoothness that's needed. So we are working with the data center industry, not specifically yet on bringing them to the west of Ireland, but maybe that's the next stage.
Okay, I'm just conscious of the time. I have just two questions left, and then we'll wrap it up. You mentioned that Germany's appointed a hydrogen commissioner for supply, scouring the world for supply.
Yeah.
Is there a role in Ireland, do you think, for a hydrogen commissioner for production?
For
driving production in Ireland?
Well, I don't know if it's the role of one person, but we are certainly very eager to see the development or the launch of this hydrogen strategy in Ireland. We've been told that it will be launched towards the end of the summer, and that will kind of be Ireland sort of laying out its stall in terms of hydrogen, because when the German commissioner came here and his Dutch counterpart visited here as well, they were met with a bunch of enthusiastic people like me and a bunch of enthusiastic people in industry and in the ports, but everyone operates in a regulated environment, and there needs to be some statement of intent from the Irish government, and that's usually where the conversations end, is that, well, I hope we get a strategy soon, because we're all sort of waiting and modeling and giving talks until we get a clear steer of where we're supposed to be going.
Okay, well, hopefully that position will clarify. And just one, so I suppose a minor question, really, just as I picked it up from your slide on Galway's particular role in this, and I suppose a generic question: what skills do you think, or new skills, or what will industry be looking for, or what new things will academia need to produce to drive and sustain this hydrogen future?
Yeah, well, I think there's, God, this could be opening up a whole other hour of conversations, but like there's the skills that are needed, and then there's also the skills that we have in Galway and Ireland that can be sort of repurposed. Ireland has led the world in bringing variable renewable energy onto the electricity grid. No, the only country with more renewable energy, with more wind energy on their grid than Ireland, is Denmark. And the Danish grid is not an island grid. We are an islanded grid. And the expertise in engineering, electrical engineering, the control systems needed for that is absolutely superb in Ireland, and that is an expertise that we can export around the world, and that's one that we'll need more of as hydrogen starts to play a role in the system. But there is a whole tier of professional skills that we in Ireland are not particularly good at producing yet, and that's skilled tradespeople, the people that are going to actually install the hydrogen systems, to maintain them, to take care of the safety. This is something that we really need in Ireland, and we haven't been great at nurturing that sector, if you like, the trade sector, the apprentices, the highly skilled apprentices. So we need more of that in Ireland.
Okay, well then I think I'd just like to maybe wrap it up there, and thank you, Rory, for painting, in these dark times, painting a future based on a resource that is all about us and all around us, and it's up to us really to rise to the challenge of trying to harness it and to bring the skills, the technologies, the processes, the people, the policies together to allow us to exploit that to its fullest. So with that, Rory, just want to thank you again, and to thank the audience, and to thank everybody in the AtlanTec support community here for allowing us to bring you this very interesting topic today. All right, thank you.
Thank you very much. Bye, Ian. Thank you.